Principles of exercise training. Previous chapters examining the acute response to exercise were concerned with the body's immediate response to a single exercise bout. We now investigate how the body responds to repeated bouts of exercise performed over a period of time, that is, exercise training. When one performs regular exercise over a period of weeks, the body adapts physiologically. The physiological adaptations that occur when proper training principles are followed improve both exercise capacity and sports performance. With resistance training, the muscles become stronger. With aerobic training, the heart and lungs become more efficient and endurance capacity increases. With high intensity anaerobic training, the neuromuscular, metabolic, and cardiovascular system adapts for allowing the person to generate more adenosine triphosphate ATP per unit of time, thus increasing muscular endurance and speed of movement over short periods of time. These adaptations are highly specific to the type of training done. Before investigating specific adaptations to training, this chapter first looks at the basic terminology and general principles used in the exercise training, then gives an overview of the elements of proper training programs. Terminology. Before discussing the principles of exercise training, we first define key terms that will be used throughout the rest of this book. Muscular strength. Strength is defined as the maximal force that a muscle or muscle group can generate. Someone with maximal capacity to bench press 100 kg has twice the strength of someone who can bench press 50 kg. In this example, strength is defined as the maximum weight the individual can lift with one single effort. This is referred to as one repetition maximum or 1 RM. To determine 1 RM in the weight room or fitness center, people select a weight that they know they can execute several repetitions. If they can perform more than one repetition, they add weight and try again to execute several repetitions. This continues until the person is unable to lift the weight more than a single repetition. This last weight that can be lifted only once is the 1 RM for that particular exercise. Muscle strength can be accurately measured in the research laboratory through use of specialized equipment research that allows quantification of static strength and dynamic strength at various speeds and various angles in the joint's range of motion. Gains in muscular strength involve changes in both the structure. Following chapter. Muscular power. Power is defined as the rate of performing work, thus the product of force and velocity. Maximal muscular power, generally referred to simply as power, is the explosive aspect of strength, the product of strength and speed of movement. Power is equal to force into distance by time, where force is strength and distance by time is speed. Consider an example. Two individuals can bench press 200 kg, moving the weight the same distance from where the bar touches the chest to the position of full extension, but the one who can do it in a half time has twice the power of the slower individual. This is illustrated in table 9.1. In focus, maximal muscular power is the functional application of both strength and speed of movement. It is a key component in almost every sport. Although absolute strength is an important component of performance, power is even more important for most competitive activities. In football, for example, an offensive lineman with a bench press 1 RM of 200 kg may be unable to control a defensive lineman with a bench press of 1 RM of only 150 kg if the defensive lineman can move his 1 RM at much faster speed. The offensive lineman is 50 kg stronger, but the defensive lineman's faster speed coupled with adequate strength could give him the performance edge. Although field tests are available to estimate power, these tests are generally not very specific to the power because their results are affected by factors other than power. Power can be measured, however, through use of more sophisticated electronic devices such as the one depicted in Figure 9.1. Throughout this book, the primary concern is with issues of muscular strength, with only brief mention of muscular power. Recall that power has two components, strength and speed. Speed is a more innate quality that changes little with training. Thus, improvements in power follow improvements in strength gained through traditional resistance training programs. However, high power output exercises such as vertical jump training have been shown to increase power for those specific movements. Endurance. Many sporting activities depend on the muscle's ability to repeatedly develop or sustain submaximal forces or to do both. This capacity to perform repeated muscle contractions or to sustain a contraction over time is termed muscular endurance. Examples of muscular endurance include performing sit ups or push ups or sustaining force for an extended period of time, as when one is attempting to pin an opponent in wrestling. Although several excellent laboratory techniques are available to directly measure muscular endurance, a simple way to estimate it is to assess the maximum number of repetitions one can perform at a given percentage of one RM. For example, a man who has one RM for the bench press of 100 kg could evaluate his muscular endurance independent of his muscular strength by measuring how many repetitions he could perform at, for example, 75% of the load, 75 kg or 165 lb. Muscular endurance is increased through gains in muscular strength and through changes in local metabolic and cardiovascular function. Metabolic and circulatory adaptations that occur with training are discussed in Chapter 11. Table 9.1 illustrates the functional differences between strength, power, and muscular endurance in three athletes. The actual values have been greatly exaggerated for the purpose of illustration. From this table, we can see that although athlete A has half the strength of athletes B and C, he has twice the power of athlete B and is equal in power to athlete C. Therefore, because of his fast speed of movement, his lack of strength does not seriously limit his power output. Also, for purposes of designing training programs, athlete A should focus training on developing strength without losing speed. Athlete B should focus training on developing speed of movement, although this is unlikely to change much, and athlete C should focus training on developing muscular endurance. These recommendations are made assuming that each athlete needs to optimize performance in each of these three areas. Power. Aerobic power is defined as the rate of energy release by cellular metabolic processes that depend upon the availability and involvement of oxygen. Maximal aerobic powers refer to the maximal capacity for aerobic resynthesis of ATP and is synonymous with the terms aerobic capacity and maximal oxygen uptake VO2 max. Maximal aerobic power is limited primarily by the cardiovascular system and to a lesser extent by respiration and metabolism. The best laboratory test of aerobic power is graded exercise test to exhaustion, during which as discussed in detail in Chapter 5, a number of submaximal and maximal field tests using walking, jogging, running, cycling, swimming, and rowing have been developed to estimate VO2 max without the need to actually measure it in the laboratory. Anaerobic power. Anaerobic power is defined as the rate of energy release by cellular metabolic processes that function without the involvement of oxygen. Maximal anaerobic power or anaerobic capacity is defined as the maximal capacity of the anaerobic system, ATP PCR system, and anaerobic glycolytic system to produce ATP. Unlike the situation with aerobic power, there is no universally accepted laboratory test to determine anaerobic power. Several tests provide estimates of maximal anaerobic power as discussed in Chapter 5 and include the maximal accumulated oxygen deficit, the critical power test, and the Wingate anaerobic test. To the ability of a muscle to exert force. Muscular power is the rate of performing work or the product of force and velocity. Muscular endurance is the capacity to sustain a static contraction or to maintain repeated muscle contractions. Maximal aerobic power or aerobic capacity is the maximal capacity of aerobic resynthesis of ATP. Maximal anaerobic power or anaerobic capacity is defined as the maximal capacity of the anaerobic system to produce ATP.